Hello viewers, my name is Larry. In this lesson, we'll be looking at the titration calculations. But before I start, I would like to complete my explanation on quantitative analysis, which I started in my previous video. And what I will be saying, number one, would be on standardization of a solution. This is the determination of unknown concentration of A using standard solution of B. For example, if you know the concentration of your acid, you can use it to get the concentration of your base through titration. So when we say standardization, it means there is a standard or a known concentration which we are going to use to get an unknown concentration. Just like when you have a football field that we call a standard stadium, and you want to build another standard stadium, it means you will use the dimension, the measurement they used for the previous stadium to design the new stadium. So it means you are standardizing. So another point is importance of titration. What is the essence of titration, especially the acid-base titration? One is to standardize, just as I said. That means we do titration so that we can get an unknown value, maybe an unknown volume, unknown concentration, using the one that is known. So one of the importances of titration is to standardize. Number two is to determine relative molecular mass of your acid or your base. So it means in the process of doing your titration, you get some values and then you use it to calculate your relative molecular mass. It can also be used for mole ratio of your acid and your base. So you know from your CAVE over CBVB, which is equal to Na over Nb. Meaning that if you don't know your Na over Nb, you can produce it from your CAVE after you have been given Ca, for example, and you have used it to standardize or to get Cb, so then you can apply. Then another importance of titration is that you can use it for percentage purity. It means in your calculation of titration, you notice that you can say find the percentage purity or impurity in maybe your base, especially base most times. So meaning that if you want to do that, you will have to use the grams per dm cube, which you must have produced. That's the mass concentration, which you must have produced from the moles per dm cube they gave you. So that's when you use purity over impurity times 100. So the mass concentration of purity and that of impurity times 100. So you can also use to get water of crystallization. Sometimes they will give you a question that we have, for example, Na2CO3 dot X H2O, and then they will ask you to find the X. Then number 6, for solubility, you can also use titration to know or to find out the solubility of the substance you are using, then also to determine the degree of hardness. So in your titration process, so you can also know the degree of hardness of the substance you are using. Then number 8, for Na or Nb, that means your mole. So you can use to get the mole of acid, mole of base. Then finally, to prepare salt, remember acid and base will give us salt. So this is the first conclusion of the previous video. Then the second conclusion is precautions. When you are doing your titration, what are the precautions that must be taken? One, rinse your burette and pipettes so that you can get good result. Avoid bubbles. Bubbles also affect result. Bubbles in your pipette, bubbles in your pipette and burette. Avoid blowing pipette. You know, when you are done using your pipette, there is tendency that you still have a small portion of base inside the pipette, so don't blow. Avoid parallax error when you are viewing or checking the calibrated side of your burette. Avoid spillage It means while making use of your burette, as the acid is coming out, so be careful the way it comes out. So you make sure you direct it straight into the conical flask. Then never rinse conical flask with its solution. When you transfer your base into your conical flask, so the base will be there. You add your indicator. By the time you want to do another one, don't rinse with the base, because if you rinse it with the base and still transferring base into it, it means you are taking more than the normal expectation. Then number 7, clamp your burette vertically. So don't bend your burette so that you don't get error. Remove funnel before reading. Remember, you use your funnel to run your acid into the burette. So once you are done, first remove before you start calculation. Otherwise, drops from the funnel will still be adding to what you have in your burette. Then avoid tap or clip leakage. The tap at the mouth of your burette should not be leaking, so confirm that before you continue your practical. Then number 10, use 2 to 3 drops of indicator for sharp endpoint. So when using your indicator, it should be within 2 and 3 drops. Then number 11, swirl. So what does it mean to swirl? That's when you are mixing or when you are turning your mixture. So swirl conical flask for homogeneous mixture. That means as the acid is coming to mix with the base which you have added indicator to, you start swirling. As you are adding the acid, you start swirling so that it can mix. Then number 12, use white tile to prevent overshooting endpoint. So it means on top of the base of the retor stand where you will place your conical flask, you put a white tile there so that when the color of the mixture has changed, you'll be able to stop immediately. So then number 13, read 2 decimal points of burette. Your burette, maybe when you are the color of your mixture has changed and you want to read from your burette, maybe it's 24. So let's say always be 24.00. Then the last one, observe concordant values. So on your table, when you are drawing your table, make sure you have a concordant value. Concordant means maybe if you have 24.0 the first time, the next time at least have 24.0 again, or 24.1 or 24.2, or it may be 23.9 or 23.8, at least plus or minus 0.2. So that's what we call concordant value. So that's the conclusion of the titration or quantitative analysis. Now I want to move to calculation. And before we start this calculation, take note of these 8 points that will help you so that when you see your calculation question, you will not start thinking before you know what to do. The first thing is that if you notice that there is a complete data, use this formula CAVA over CBVB equal to NA. A good example is found in year 2024. Now look at 2024 question. Look at the parameters they gave us. So from the parameters, they gave us CA, they gave us VA. That CA, take note, in moles per dm cube, not grams per dm cube. So if they give you CA in mole per dm cube, VM, your volume cm cube, then NA, which is 1. That means that's CA, VA, NA. These are 3 things we need. Then the second one must be unknown. 1. So CB is unknown. We know our VB, we know our MB. So meaning that it's easier to use what CA, VA over CB, VB equal to NA over NB. So that's number 1 thing. Then number 2 is that if we now have 2 unknowns, then we cannot use CAVA. Let me merge it with number 3, except if the 2 unknowns are NA over NB. That means if you don't know number of moles A, number of moles B, if that's the only unknown. So these unknowns of NA and NB you don't know, they may ask you to find mole ratio. So it means you can still apply that CAVA, CBVB, since both of them can turn to ratio, so we can still plug in our values into CAVA, CBVB. But take note of this number 2, that 2 unknowns can't use CAVA aside if it is NA, NB. So where can we find this? So for this, we can see in 2025 and then 23. So let's check 2025. Now, if you look at in this 2025, so you notice that we have, so let me come down here. Okay, now look at the values that they gave us, the parameters. Let's start from CA. So see, there is no CA, though we have VA, we have NA. Then come to CB again, there is no CB again, but we have VB, meaning that there's two unknowns. When I say whenever we have two unknowns, we cannot use CAVA immediately. So what will you rather do is that for the CA, they ask you to find. So you will first have to convert, you do some conversion, because in CA they gave us gram in cm cube. So you have to first change gram in cm cube to grams per dm cube, which I did here. So how will you do it? The grams per cm cube means the number of the gram over number of the cm cube. So change the cm cube to dm cube by dividing by 1000. Then you get your grams per dm cube. Then that grams per dm cube again, you now go and convert it to cm cube. To mole per dm cube. So once you convert it to mole per dm cube, it means we will have our Ca. So it will now be only Cb we'll be looking for. Then we can use our CAVA. So the workings are here. So as you can see, the gram per dm cube. So after I've converted it, I've produced grams per dm cube. Then I can now change it to moles per dm cube. So using this formula. So after changing to mole per dm cube, then I can come back to CAVA, CBVB. So that is for 2025. Then I also said in 2023 we can see two unknowns also, but we are still, so this is it here. So we can see two unknowns as well, like NA is unknown and also NB is unknown. So in this case, they ask us to find mole ratio. So normally we ought not to use CAVA, but because it's the two of them together as mole ratio, then we can still apply CAVA. So by the time we apply this formula, then these two unknowns will become the two ratio that we'll be getting. So that is another point. Then another point we need to know is point 4, that most times if grams in cm cube are given separately, especially in B, that's in base, or so though it's not always base, but most times it's base, but it may not be in some cases. So if grams in cm cube are given separately in B for impurity or percentage, so don't use any number given until the last line as denominator. So the last line, it means, for example, assuming they say 5 grams in 100 cm cube. 5 grams in 100 cm cube. It means that 5 grams are in cm cube. I'll turn it to 5 grams over that 100 cm cube and still divide that 100 cm cube by 1000, so that I will turn it to grams per dm cube. And take note, that grams per dm cube I got, I will not use it throughout the workings in that question until I reach the last line where they may ask me to find the percentage purity. Then I'll come and put that grams per dm cube as a denominator because it will represent impurity. There's a formula that says purity over impurity times 100. You can say pimples, P-I-M-P. So it means that impurity which is under, that's where you come and put the grams per dm cube in the question. That's the gram per dm cube that they gave us in B as grams in cm cube, which we converted to grams per dm cube. So that is for number 4. But at times, this gram in cm cube we are talking about, we will first convert to grams per dm cube and then later moles per dm cube. But take note of this number 4 very well. It's always confusing. This number 4 is the most confusing of all the questions. So most times, these grams in cm cube are given separately in B. For impurity or percentage, don't use any of it till you get to the last line. So you can see, you will see it in 2025, 2024, and 2019. So let's look at 2025. That's why I use red ink to underline the 2025. See here, they say B contains 4 grams of impure NaHCO3 per 250 cm cube of solution. Anytime you see this, that they separate the grams from the cm cube, that's for B, and they now still use the word impure. Sometimes they may not use the word impure, but you will still know, you will notice that it's still the one in some cases. Now let's see, how do we solve this? So take note that this 4 grams in 250 cm cube, you will never see it being used from the beginning to the end. 4 grams, see, 4 grams in 250 cm cube, I'm not going to use it at all. So nothing like 4 grams here. From the continuation of the working, You will never see 4 grams here. See, no 4 grams until I reach the end. So no 4 grams here also being used, no 4 grams. Now look at the last question, the percentage purity. So that's when I now brought the 4 grams in 250 cm cube, means over 250 cm cube, and I will still change cm cube to dm cube. That's by dividing by 1000. So meaning the result I have will be under as denominator, which is my impurity, the impure. What of the pure? Where will I get the 5.59 of the pure? So for this one, it will be from the calculation I would have used earlier. So what kind of calculation would I have used earlier? Let's go and check 5.59. See this 5.59. It means the place where they say CB in grams per dm cube. So it means if they say what is CB in grams per dm cube, don't go and make mistake and start saying, oh, since it's CB in grams per dm cube, after all, B is here, so that the grams will be 4 grams, and you change one to dm cube, and you go and write this for this question. For this Roman figure 3, the person will fail it. So, but once you understand that, okay, anytime I see grams in cm cube and they are referring to impurity, don't use it at all until you reach the end. But how will you now do this? If they say find CB in grams per dm cube, it means you will go and pick the CB that you have in moles per dm cube, because you must have gotten the CB in mole per dm cube. So just multiply by molar mass. It will help you to get a calculated grams per dm cube and not the grams per dm cube in this question here. So like I said, you can get it from the moles per dm cube you get in the question, even the moles per dm cube in the question. So you must have gotten it from the relation with CA. So CA will help you to get your CB in moles per dm cube, then you convert it to grams per dm cube. So that is for that 2025. Then also 2024, you will still see the same thing repeating itself. So just always be conscious. Now look at 2024. They said this is a solution of iron 2 plus obtained by dissolving 3.8 gram. Have you seen it now? Of iron granules in 250 cm cube. That's if they give you a gram in cm cube of solution. So, and they ask you to do some calculations. Now in this case, now you see they did not mention pure or impure. So, but they said they dissolve iron granule in something. So, as I said, that you will not use this gram and this cm cube until you get to the end. Especially, another idea you used to know is that most times they will say find the percentage of something. That's what we should remind you that, oh, this is what they are referring to. Find the percentage, find the percentage. So now it means for this particular question now, the 3.8 gram in 250, you will never come across it being used. 3.8 gram, you will never see it being used at all. So 3.8 grams, see, not used until we get to the end. And at the end, I use it as impurity. That's under 3.8 in 250 cm cube. I change the 250 cm cube by dividing by 1000, turn it to dm cube. So then how will I get the pure one, the pure grams per dm cube in my numerator? So I will get that one from my calculations. So you will see that there will be a place where I would have gotten grams per dm cube for my B. So the 4.06, let's search for it now. See, as you can see it here, 4.06 grams per dm cube. So we've calculated for it here in CB. And that 4.06, how did we arrive at that also? It means they must have given you moles per dm cube of your CB, and that is also from your calculation. So that's moles per dm cube of CB. We'll first change it to grams per dm cube of CB, and that's what we'll use for the numerator. That's the pure on top. So before we times by 100 and get our percentage. So the third place where we used this same explanation is in 2019. So this is to confirm or to prove the point that is appeared in 3 different places, and we did it the same way. So now look at 2019. So what did you notice? It said B was obtained by dissolving 9 grams, here they stated it emphatically, of impure iodine in so and so on to 1 dm cube. So once they separate this gram for D from cm cube or dm cube, and it's for B, take note, it means it will be at the end. And since they use the word impure, so meaning at the end, that's when we use 9 grams of this 1 dm cube. So let's watch it out. So you see that 9 grams was not used from the beginning, nothing like 9 grams from the beginning. So until I get to the end. So this 1C is just extra question, but 9 grams C is now on at the end. So 9 grams in 1 dm cube means per 1. So per 1, you don't need to convert to dm cube again, it's already in 1 dm cube. So I use it as denominator, which is my impure. Then which means my pure will be on top here. So my pure will be on top. Now, and that pure means the grams per dm cube, which must have been calculated along the alongside. So let's go and check the grams per dm cube which has been calculated while solving. So that's 0.025 moles per dm cube. So moles per dm cube, there must be a B that is mole per dm cube 0.025. Then multiplied by 254 molar mass. So let's go and check 0.025 moles per dm cube. So this is it here, the 0.025 moles per dm cube. So that's the B. So by that we multiply by molar mass, so it will give us the grams per dm cube. So meaning that the upper one, this numerator, is always a calculated one from the previous one, while the denominator is always from the question at the beginning. So which is the next point. Now let's look at another point again, and that's number 5. So number 5, at times, that means that doesn't mean that every time it goes like that, but at times the gram in cm cube, they are converted to grams per dm cube. Then you change it to moles per dm cube. So like that same 2025, so they may give you a gram in cm cube, so and you need to convert it to gram per dm cube, and then you may use it for your moles per dm cube. Now look at this 2025. That means look at grams in cm cube, they gave us in A, even though they still gave us in B. So I've explained how to do that of B, but that of A, which is grams in cm cube, so we said it can also change that one directly to grams per dm cube. So let's watch 0.825. So from the beginning, that one would have been settled, you would have used that one. So see it here, from the beginning, 0.825 in 250 cm cube, we have converted this to grams per dm immediately. That's the A, if it is in A. But for B, most times it's always at the end. So that is for 0.5. Then 0.6, to find mass of X in a particular cm cube of B. So you are going to relate this, especially just like stoichiometry. Now, what do I mean by to find mass of X? Maybe they give you a question that find the mass of iron that is in 20 cm cube of the base, maybe the base of iron salts. So they say what is the mass of the iron inside that iron, inside 20 cm cube of that iron salt. So since they use the word mass, it means we are looking for the mass of iron. Put X as the mass of iron, then use line, you roll a line like this. So since they say 20 cm cube, it means the gram, X gram equal to what? 20 cm cube. But that cm cube, immediately change it to dm cube, you say over 1000. Then it means you have already formed grams per dm cube from the question. Then you now take another grams per dm cube from your answer that you must have gotten before. So maybe you have gotten a grams per dm cube before in your B. Just take that grams per dm cube, separate it. So by saying 4 grams, that per dm cube means equal to 1. So remember, we are looking for the mass X gram, and then they say in 20 cm cube, which we have converted to dm cube, you say equal to 20. Then from the grams per dm cube, you must have gotten the question before for B. So let's say 4 grams per dm cube, we also say 4 equal to 1, then you cross multiply and you get that mass. Where can we see this? Like in question 2024. So let's check out for it in 2024. So this is 2024. So the question, we see it in, let's look at where they will say we should find the mass of air. Look at it. Find the mass of iron in 250 cm cube of B. What will you first do? Since they say I should find the mass of iron, put G here. That I'm looking for the mass of iron. Then in 250 cm cube, this is the 250 cm cube. Now, I now said that you will now use the grams per dm cube they have given you before, which is also for B. Take note for B. So if you go up, so this is 4.06 grams per DMQ for B. So that 4.06 grams per day, I'll now bring it down. That 4.06 equal to, so that per DMQ is same thing as 1000 cm3. Why? Because since this one is already in 250 cm3, you may not bother dividing by 1000 and leaving this one as 1 DMQ, though you still get the same answer. Either both of them are in CMQ or DMQ. So with that, you can find the mass of what they ask you to get. Then another likely question number, so as it is for grams, so it is for mole. Sometimes you can say find the mole of something. So the way I use grams per DMQ, you will use moles per DMQ. So and that's what I wrote in number 7. That if they ask you to find gram, use your gram per DMQ times the volume they give you, because they will give you a volume. They will say find the mass of an element in 25 cm3 or in 10 cm3. So if they say in a titrated volume, it means once you take your grams per DMQ of that particular, for example, if it is acid, so take gram per DMQ of the acid times the titer value in cm3 over 1000, so it will become DMQ. So and if it is in a base, if they say in base or in the pipetted substance, in the pipetted, so if you want to find the gram in the pipetted, so just say the grams per DMQ of that base that you have gotten times the pipetted, means times 25, so over 1000, so use it to get. Then it may also say you should find the mole of the acid. So maybe they must have given a moles per DMQ that you have gotten the acid, that's Ca. So just times it by the titer value if they ask you that in the titrated substance. So that's maybe 22 point something, so over 100. So use it to get your mole. And to find grams per DMQ also, they may say find grams per DMQ in the question. First confirm, is there molar mass? If there is molar mass, then that grams per DMQ will now say equal to mole per DMQ times molar mass. So and there is one last question which you will see, which is for carbon dioxide. So that kind of question, let me just go and check and show you. So this is the question I'm referring to as carbon dioxide. So in this is the last question here. So meaning, is it 2015 for CO2? Okay, it's not 2015. Now this is it, 2016. So in 2016 they talked about CO2, that you should calculate the volume of CO2 evolved at STP. Once we hear volume of a gas, because CO2 is a gas, and you hear STP, meaning that you are going to use 22.4 DMQ in your calculation. And to get volume, immediately you find volume. So and in your chemical equation, because they will give you a chemical, look at this chemical equation. So if they say find the volume of CO2, meaning that you underline this 10 CO2, you need it. In this oxalic acid, so this oxalic acid you also underline. These are the two major things, the oxalic acid and the 10 CO2. You bring both of them together, so they are here already. So which means from here now, if they say calculate volume of CO2, it means this CO2 I'm looking for the volume, but I will not do that immediately. I will not just say okay, I'm looking for volume, I should write V. And they said at STP when 25 cm3 of oxalic acid, and I should now quickly write 25 cm3 and say I'm looking for volume. No, this is what I will do. I will say okay, since the volume I'm looking for is related to mole, because there is 10 mole, there is 5 mole. I will now first get mole. Once I'm done with mole, then I'll change it to the volume they asked me to find. So like the mole here is 10, the mole here is 5. I will say 5 is equal to 10. Then the 25 cm3 they give me here, I'll first change it to DMQ, that's over 1000, it will turn to DMQ. Then because they are talking about volume, I'll remember mole per DMQ. Just as I said, I will first use mole here. So meaning that I will use mole per DMQ that they have given me, which is from this oxalic acid. So I'll go and pick the mole per dm cube of the oxalic acid. So use it to convert this one to mole. So meaning that it will now be mole to mole, mole to mole. So after I've calculated the mole here, so equal to the mole unknown mole that is here, then this 10 and 5 and cross multiply to get the mole of this CO2. Now that I know the mole of the CO2, so I will now say normally 1 mole of CO2 is 22.4. But now that I've gotten a new mole, so what will that new mole be across multiply to get my answer? So take note, I wrote 56 cm cube here, so mean that in dm cube it will be 0.056 dm cube. So these are the rules. Once you follow this rule, you can solve all the questions. So let's take the questions one after the other. So here we have about 10 calculation questions. I'll be very fast since I've given the rules, so I don't need to waste time on that. Look at 2025, this latest question here. They said A was prepared by dissolving 0.825 grams of HCl in 250 cm cube of water. B contains 4 grams of impure NaHCO3 per 250 cm cube of solution. Then it said do all these calculations, put your A in the burette and so on. So the first thing you should always remember is the volume of your pipettes, because they can use 25, they can use 20, but it depends on what your school is using. So most times it's 25. So just indicate that okay, the VB you use was 25. Then because they say tabulate, you draw your table, and then what are the things you have on your table? Your burette reading. But always try this one in full and put the units inside CMQ. Then your rough first, second, titer also in CMQ. Then you can say FIV, that's 5 FIV, final burette reading, initial burette reading, volume of hay used. Then all these ones are calculations, are not values you get when you conduct your practical. That initially, before you start your titration, you're always starting from 0. But once it gets to a point that color has changed, you check the value, so which is, let's say 18.5, then you subtract and you write your answer here. So you repeat it 3 times. So after repeating it 3 times, the next thing is that there are 2 concordant values you need. Those ones that are very close to that, their difference is not more than 2. Like these 2 here, they are concordant values. So one in the marking scheme, they always mark these 2 concordant values as 8 marks. So take note of that. Then they also always mark the average titer value or average volume of A, meaning when you add both of them, divide by 2, you get your answer. Take note, it must be in 2 decimal places. Then you can now take another calculation. It said from your calculation that calculate CA in moles per dm. So to calculate CA in moles per dm, first write out your parameter that A is an acid, HCl, and they gave us these values, grams in cm3. This VA means the average titer you have here, 18.30. Na, remember HCl, so you get your Na from your chemical reaction. So this is my chemical reaction, and this is my A acid, invisible one is at the back. So make my Na equal to 1. Then for B, you write the name of the compound, B, this is it, and they said 4 grams of this impure per 250 cm. Then that's B. Take notes while you are writing your parameter. The first thing that should be in your mind, CAVENA, CBVBNB. So we have written CAVENA, remaining CB. So CB did not give us. VB, take notes, is always 25. That's your pipette. Then NB, you go and check this base, NHCO3, in your chemical equation. See it's your invisible one. So that's your NB, you put it there. Now from here, I underline with red pen. That means they are unknown. And I said it earlier, whenever you have 2 unknowns, you cannot quickly use CAV. So meaning that if I want to get this CB, because the question here says we should calculate CA, sorry. So it means if I want to get CA first, because the question says find CA. So what will I do? It means I will, since I cannot use CAV, CBV, all I will do is that what other information do I have for A? So it means for A, I still have gram in CMQ. So I can use that to get my what? Moles per dm3. So that gram in cm3 means I'll just divide over this, then convert it to dm3. So I've gotten it in grams per dm3. Then I'll now turn it to what? Moles per dm3. They asked me to do that by multiplying by molar mass of that acid HCl, which is 36.5. But if they did not give me this, I may not use that formula. So this is workings here. So how the grams per dm3 become moles per dm3 times molar mass. So from there, I have already gotten grams per DNQ. I'll divide it by molar mass, so I've gotten my CA. Remember, initially we don't know CA, but now we have our CA, so we can now use our CAVA because it's no more two unknowns. We have known our CA, so to get CB, we can now use CAVA, CBVB to calculate, so that you get your answer in moles per DNQ. Then take note, your answer must always be to three significant figures. So that's from significant start from this 6. 0 is not relevant, so just say 6 1 7 2. Actually there should still be 0 here, so remember to put 0 here to complete 3 significant. So let me add it so that you can see it. So 0.0670. So that's how WAEC standard is. Otherwise they will reduce mark. As you can see, each of them 1 mark. And take note of the way I mark this first one, because I will not repeat it in the next question. So after they mark your concordant value 8 marks, they mark your answer 2 marks. So that's your average titan 2 marks. Then another thing they always mark is, okay, like this one, grams per DMQ 1 mark. You must include your the molar mass. How did you get the molar mass? Don't just say the 36.5. Don't just go and use 36.5 immediately, but show the workings, because it's also 1 mark. Then also the CA you got, there was also 1 mark for it. CB, the calculation. Take note of this formula, CAVA and so on. Make sure you first write the formula like this. Then after writing like this, CB you are looking for, make it subject of the formula before you plug in your values. So after doing that, so that arrangement has 1 mark on its own. So it has 1 mark on its own. So when you plug in the values, then the answer you now got also has another 1 mark on its own. So and that's how it is for grams per DMQ. So if you are looking for grams per DMQ, you plug in your value, there is 1 mark for that. Your answer, there's another 1 mark for that. Then since in this one you multiply by molar mass, you must also show how did you get your molar mass. So you show the workings, another 1 mark. So the percentage purity, the way you plug in your data, your value, there's 1 mark. Your answer, there's 1 mark. So that is for that aspect. So that is for 2025. So meaning in 2024, I will not do much explanations. So I will just go straight to the point. So 24 says A is a solution of KMNO4 containing this mole per DNK, and B is a solution of iron 2 plus obtained by dissolving 3.8 grams of iron in 250 cl of solution, and so on. So the first, as I said, your table. So but here I'm not drawing the table again. You've seen the pattern. All I need is the concordant values. So look at these two things. The difference is just 0.2. You have your 4 marks, which is 8 marks. The average volume of A, which is the addition of these 2 over 2, your answer again 2 decimal places. Take note and remember to put your units. So that's 2 marks. Then here now we are to calculate CB in moles per DMQ. So how will I calculate my CB? First write out your parameters. From this parameter you can see that everything is complete. They gave us CAV, NA. Then we are looking for only CB. Then we have VB and NB. So we can use our CAV, plug in your values. Remember, always remember 3 significant figures if you are dealing with concentration. So moles per DMQ. Then they also say we should find CB in grams per DMQ. So since I have my CB in moles per DMQ, I'll just use mole per DMQ times molar mass. But always make sure you indicate the molar mass. 56, how did you get it? Put in there, because it attracts mark. So from here I always say GMM, good morning. So remember this conversion of grams per DMQ to moles per DMQ. Then the third one, find the mass of iron 2 ion in 250 cm3 of B. I said that earlier, that if they say find mass, you put G there, grams unknown. So in 250, that means equal to 250 cm3. So from that gram and cm3, remember grams per DMQ. So mean that you go and bring the grams per DMQ that is here, which is 4.06 grams per DMQ, means inside 1000 cm3. Then you use it to get your calculation when you cross multiply. So then the next one, the percentage. I've taught you how to mention or how to calculate percentage of a substance. So meaning that you take your pure over impure. So the impure is always gotten from the question at the beginning. The one I said from the beginning, you bring it down. So while the pure will be from the recent calculations that you must have gotten, like this 4.06. So that's how we get the pure. So I've explained that earlier. So like I said, I won't waste time. Now 2023 here says A is 0.1 mole per dm cube of HCl, B is 0.03 moles per dm cube of triazocarbonate 4. So put A in. So all those steps. The first thing, always remember to write the volume of pipettes you use. Draw your table. The major focus is concordant values. So that means those ones that are close to 0.2. So each of them has 4 marks. You average volume, add them over 2. You get your mark there, 2 marks. So this one in cm3. Put your unit every time. Then here now another question says calculate mole ratio of acid to triazocarbonate in the reaction. So since it says to calculate mole ratio, it means first write out your parameters. These are the parameters, meaning Na and Nb, they are not given. So meaning they are the ones that will give us our mole ratio. That's why I said earlier that normally when there are two unknowns, we don't use CAVA. But now, because the two unknowns are moles and they ask us to find them in ratio, so we can use the CAV. Any answer you got there, so will become your ratio. So Na and B. So then you give reason. Here they say given that B contains 5 grams per dm of hydrated triazocarbonate, calculate concentration of anhydrous salt in B in grams per dm. Now this one here, take note. They have given us 5 grams per dm as hydrated. That means when there is water there, it was 5. What of anhydrous? When there is no water there, it means the number will be smaller than 5. In this case, it means the 5 which is having water, you subtract something from it, as you can see from here. So where is it? Okay, so as you can see from here, the 5 minus 3.18. But before we get to that point, because there are two questions there, so they say given that B contains 5 grams per dm cube of hydrated triazocarbonate, calculate concentration of anhydrous salt. So the first thing you do here is that CB in grams per dm cube. CB in grams per dm, that's question mark. That's I'm talking about the parameters from the beginning. So parameter that means CB in grams per dm is unknown. CB in moles per dm cube is 0.03, and then the molar mass is 106. So meaning that our grams per dm cube will be what? The mole per dm cube that is here times 106. So that's to get anhydrous. Grams per dm cube of anhydrous. But here, the grams per dm cube they give us is for hydrated. So it means it's giving us logic of that pure over impure. That means there must be 2 grams per dm cube if you want to do your calculations here. Let's go back to the question. So from this question here, for B, they did not separate grams from cm cube. They only give us mole per dm cube. So as when they separated it, we would have used it at the end, but nothing like that. So it means you don't need to bring it to the end. But this is what you just do. You say, okay, for hydrated, which is 5, they give me hydrated one that has water as 5. Then it means there must also be a grams per dm cube for the one that does not have water, which we call anhydrous. So how will I get that kind of grams per dm cube? So I will just use moles per dm cube times molar mass. So mole per dm cube of the anhydrous is 0.03 mole per dm cube for the anhydrous. So as you can see it here, 0.03 moles per dm cube of triazocarbonate. So that's the anhydrous. So that moles per dm cube now times it by the molar mass of that same triazocarbonate. As they have said it, the anhydrous, see, they mentioned emphatically that the anhydrous molar mass is 106. So you use it to multiply this moles per dm cube 0.03. So after multiplying that, you get your grams per dm cube for anhydrous, because they only give us the hydrated, which is 5. So it means that hydrated 5, the one that has water minus one that does not have water. So it means it will now remain the answer, which is that answer is now only your water now. So then it will now, if that is your water, you now say divided by everything. That means the one that has water. So only water over the salt with water, which is 5. So they times it by 100. Then use it to get your percentage. Then finally, number of moles of hydrogen ion in average titer. So this was talking about number of particles, number of hydrogen ions in average titer. So since they are saying average titer, titer is for volume of acid, meaning that you go and bring the acid in the question HCl, and HCl, when you ionize it, you have H plus and Cl minus, and their moles, they are 1 1. So no 2 there, 1 1. So meaning if they say find the number of moles of H plus, put X under it. That means I don't know the number of moles of H plus. But when you come to acid HCl, when its own number of moles is CV. From that means you can say no CV, no curriculum vitae. So its own number of mole is CV. Meaning that HCl they must have given you a moles per dm cube, which is 0.1. Then volume is that average titer, so which is 20.4. But remember to divide by 1000 so that it become dm cube. So any answer you have there, relate it with this X. That means the mole we are looking for. Then you now go back to the beginning, that the mole are the invisible one here, you bring it down. Then for this HCl also there is invisible one, bring it down, you cross multiply and use it to get the moles of this one they ask you to find. So that's for this question. Then we move to 2022 that says A is an aqueous solution of iodine, B is 0.1 moles per dm cube of thiosulfate, sodium thiosulfate, put B into burette, and so on. So this one now is a redox titration. Redox titration. So don't be panic, it's still the same method. So always remember, try volume of your pipette, you draw your table, the concordant value, those ones that are 0.2 difference, add them together over 2, get your volume. Then the second calculates concentration in moles per dm cube of iodine in A. So to do this, first write out your parameters, that your A is iodine, and they ask us to find Ca, or just say we don't know Ca from the question. Va is always your titer value, Na 1. Why is Na 1? From iodine, you go and look at the formula or chemical reaction. So iodine invisible 1, not this 2 that is under, but the one at the back. So Na is 1. Then you go for B. B, your thiosulfate. What is the CB? They gave you 0.1, and the VB. So now take note of this. Here there is a kind of confusion they want to bring. Normally VA is always the acid, the titer value, maybe 12 point something, 23 point something, that VB should now be 25. But this time they intentionally change it to confuse students. So make sure you follow according to the question. So VB this time is 12.55, not the standard VB of 25. So the standard 25 is given to VA. And how will you know it's from the question? So like here now, they will say you should put add B from burette. You can see normally it's add A from burette. So as long as A from burette, that will be our titer value. But now since it's B from burette, it means B will be carrying the volume of A, while A will be carrying the volume of B. So that's how they arrive at that. Then MB. So since it's thiosulfate, you check your MB. So the thiosulfate is here is 2. So you just put it there. Then you can calculate concentration in moles per dm cube of iodine in A. So to get the concentration of iodine in A, so that's Ca. So mean that the Ca, you can apply CaVa. Why are we applying CaVa? From these parameters, we have Ca, we have Va, we have Na, we have Cb, we have Vb, and then we are looking for, it's only Ca we don't have, but we have others, so we can use our CaVa method. Then the next question is say find the mass in grams of iodine in 1 dm. Like I said, once you have find the mass, put your G there. Then in what? 1 dm. 1 dm is the same thing as 1000 cm cube. So you can divide it by 1000 if you want to change it to dm cube. So, and as I said, you now go and use the grams per dm cube that you must have calculated, and if you have not calculated it, you calculate it immediately. That's focusing on A. Anything they give you for A. So taking mole per dm cube from A times the molar mass of A, you use it to get the new grams per dm cube. So meaning that from here the molar mass of iodine, so meaning that iodine is for A, is 127 times 2, which is what 254. So it's actually 254, not just ordinary 54. So there is 2 here, so 254. So this 254, which is our molar mass, you will now times it by the moles per dm cube. That will give you your what? Your grams per dm cube. So what will I now use the grams per dm cube to do? It means I will now put it at the back of this That means my 6.375. So though it's still on the next page, but take note, it will now be here 6.375, which is the grams will be here. Then per dm cube will be on the other side. So that per dm cube means also 1000 cm cube. So with this, it's telling us that this 6.375 is 1000, then the 1000 of this one is also 6.375, and that's why we stopped it here. So if you want to follow the same pattern we followed the other time. So then after this 1BII, we now have another year question here, 2021. They say A is a solution containing 2.03 grams of HCl per 500 cm cube and so on. B is 0.12 and so on. Tabulate. So the first thing, always remember volume of your pipettes. Then you draw your table, your concordant value, those ones that their difference is no more than 0.2. So, or if even if they are the same, that's even the best. So like this one, they are the same. The average volume of A. So what will you do in average volume of A? So you add the two together over 2, get your answer. Always remember cm cube the unit. Then this question is calculate CA in moles per dm cube. What will you do? Write out your given data so that you can know if how many unknowns do you have. Like here now, they have 3 unknowns, meaning that we cannot use CAVA. So to get my CA here now, so I would rather use what other value is besides CA. So this CA now, other value that is in A is this 2.03 grams per 500, and that's what I also use to get the CA. So that's change the CM cube to dm cube, then I will use it to, that one will first give me grams per dm cube, then I will now relate it with molar mass and use it to get my CA in moles per dm cube. Now that I have my CA in moles per dm cube, so the number of moles, remember there are 3 unknowns. I will now also go and find out Na and Nb. So and that's why the next question says, what's the number of moles of A in average titer? So to get Na, just say NCV, that means no CV, no curriculum vitae for A. We'll also do that for B. So the CA, they have given us the mole per dm cube, we put it there. The VA, that's the titer value, they use it to get the moles Na. Then the same way for MB, so use your CV. So we have known the moles per dm cube of B. The VB is the volume of B, is always 25, but always remember to convert to dm cube, so over 1000, so that it can produce moles. You know, the dm cube will just cancel the dm cube of the mole per dm cube. Then finally, now say what is the mole ratio? That means the two answers that you got in this previous one, divide them, use it to get your mole ratio. Then 2020 says A is a solution containing 5 grams of HNO3 in 500 cm cube of solution, and B is a solution of NaOH of unknown concentration. Put A and so on, then tabulate. So as I said, always remember your volume of pipettes, which is always 25. Draw your table, your concordant value, those ones that their difference is no more than 0.2. Then average volume of A, joining these 2 over 2, then you get your answer. Then take note of this chemical equation. Then they say calculate CA in moles per dm cube. The first thing, write out your parameters. That means the name of your A, HNO3. And they say it contains 5 grams in this, write it out. So for the fact that they wrote grams in something does not mean that's your CA. No, CA is always in moles per dm cube. So it means we don't know our CA yet. VA, your titer value, NA. That means check your HNO3 in the chemical equation. It is a visible one, so you put it there. Then B, the name of the B is NaOH. So the CB did not give us. VB, that's base volume, always pipette, which is 25. The MB, you go and check your NaOH. So invisible one, you also put it there. Now, since we are looking for what CA in this question, so it means we are looking for CA, we are looking for CB. That's 2 unknown, meaning that we cannot use CAV. So what we now do is that the CA that you are looking for, use what is close to it beside that same A, which is 5 grams in 500 cm cube. So just say 5 grams over that 500. You say that 500 divided by 1000, so that you become grams per dm cube. Then relate it with molar mass and you become your moles per dm cube. Now we have CA, so it will now be easier for us to use CAVA so that we can use to get our CB. So for the CB, this is our new CB, most per diem cube. And you can see say change it to grams per diem cube again. So just take it and relate it to molar mass of that CB. So that's for that one. Then the next one, calculate mass of NaNO3 formed if 250 cm cube of NaOH were neutralized. Mass of NaNO3 formed. Take note of the two names, NaNO3, then NaOH. These are the two major things you need. So what will you just do is that calculate mass of NaNO3. Go and write M on that NaNO3. Write M, that means you are looking for the mass. Then if 250 cm cube of NaOH, you go to NaOH, go and write 250 cm cube there. So you will see that here now. Okay, so you can see the chemical equation now. So for NaNO3, they say what is the mass? I wrote it there. The NaOH, they said 250 cm cube. I also wrote it there. But now, say anytime you hear mass, what should first come to your mind is mass concentration, grams per dm cube. So and that's what you will use on this left. So you go and check mass per dm, grams per dm cube of this NaOH, because why are we using this? Because it's one that we have the known, but this we don't know this, so don't touch this one yet. So look for grams per dm cube of NaOH. Relate it with the 250 dimension, and remember cm cube divided by 1000, it becomes dm cube. So any value you get, so remember dm cube we cancel dm, it means one become mass. It will now be mass to mass. Then under it now, you also use a standard masses under. That means for NaNO3 its own mass, that means molar mass, you write it here. NaOH its own mass, that's molar mass 40, then you cross multiply, then you get your mass. That leads us to 2019. So A is a solution containing 15.8 grams per dm cube of sodium thiosulfate, and B was obtained by dissolving 9 grams of impure, and so on. First thing, your volume of pipette, remember a 25 cm cube. Then the table, always draw your table, get your concordant value. The one that their difference is no more than 0.2. Then the average titer value, add the two of them together over 2, put your answer in cm cube. Now they say calculate Ca in moles per dm cube. Take notes, if you want to calculate, first write out your parameters, your chemical equation, what are the values of each element. So here now, it shows that we don't know Ca and we don't know Cp, meaning we cannot use CAVA, that's CAVA. So since we cannot use CAVA, what will you do? It means to get my Ca, I will use the value that is very close to Ca. Now, if I check out, you will see that there is no value that is very close to Ca. So what will I now do to that? So it means I will, from here, I said use grams per dm cube, which is moles per dm cube times molar mass. So now from there, it means if I want to get my Ca here, so I will go and take the grams per dm cube that is given for Ca. So meaning, let's come back to this place. Okay, so it means there was a mistake there, something was not written out. So for A, there's 15.8 grams per dm cube for A, 15.8. So it means here, let me write it out. So as part of my parameters here, so I ought to write 15. So let me put it here, 15.8 grams per dm cube. So now, so this one now is for A, So meaning that since I'm looking for, let me just leave it like that. So now, as I said, since I'm looking for Ca in moles per dm cube, and we don't know both Ca and Cb, it means we cannot use CAV. So what we now do, you use the one that is beside Ca to get it. So and what is beside Ca? 15.8 grams per dm cube. Then relate it with the molar mass of this A. So both of them will now give you the moles per dm cube. So we now have Ca. So only Cb we don't know. Then we can use CAVA to get our what? Cb. And this is Cb here. Then the next question now says calculate percentage by mass of iodine. So I say once you get percentage, just remember your pure over impure, that is mass conc, grams per dm cube of pure, mass per dm cube of what? Of impure. Just say pimples, P pure, imp, IMP, impurity. So from pimples, P and imp, so times 100. Now, as I said earlier, that this one that you see under here is always from the question at the beginning. We don't use it from the beginning to the end until the end. So meaning that this 9 grams per dm cube is from the beginning. See, so that's why I underlined it, that I will not use it. I put times. That means I'm not going to use it until I reach the end. So it's always common to B. So when they say 9 grams in 1 dm cube, don't use it at all until you get to the end. So which is here 9 grams per dm cube. But the grams per dm cube you would use on top here, it will be from your calculations. So since they say of iodine, just go and look for grams per dm cube from your iodine. So and iodine is in your B. So it means from your B, every value they give you in your B, you use it for it. So meaning from our B now, remember we are getting moles per dm cube. So just change the mole per dm cube to gram per dm cube. That's related to molar mass. So just the molar mass of iodine. So use it to get the gram per dm cube you put here. So then times by 100. So they say give reason why starch indicator was not added to the titration mixture at the beginning. So because in redox they said we should add starch. So and we did not add it at the beginning. Why? To avoid inaccuracy and formation of complex mixture. Because if you add the starch from the beginning, you make the mixture so complex. It's just like when you are cooking beans and then you have added palm oil from the beginning. So it will affect the way the beans will look like at the end. Now we move to 2018, which says A is a solution of KMnO4. So A is a solution of KMnO4. B is a solution of iron 2 chloride containing 4.2 grams of the salt in 250 cm of solution. Put A into and so on, then tabulate. The first thing is always your volume of pipettes, which is 25 cm3. Then you draw your table, bring out your concordant values, which are what 15 and 16. Though there should be a slight mistake here because the difference is too wide, so it should be points. The difference should be points, not just directly. So meaning that it should be, let's say, let me try to put something that will be, so let's say 15.6 and 15.7, like trying to get the average here. Let's say 15 points, okay, let's say 15.0 and then 15.10. So that 16 is an error. So take notes. We can't use such a thing. So when we add this together, it will be 30.1. An average of 30.1 will be 15.5. So instead of this one now, it should be 15.10. So that's your concordant value. So don't ever use 15 and 16, it's very wrong. So the average now will give you your titer value. So from this average titer value, so we can calculate the next thing, CB in moles per dm cube. So to do your CB, write out your parameters. A is this, then CA is what we don't know it, then CB also we don't know it. So mean that you can't use CA VA in this question. So to get my CB, what will I do? I will check what is beside B. So beside B now, nothing was also mentioned here. So but let's confirm fully. So we should confirm fully the methods. Okay, so mean that there must be a grams per dm cube for CB. So which I have not yet touched. Okay, 4.2 grams in 250 cm. Okay, now this 2018 question appears to disobey the law that I mentioned earlier. Remember I said whenever they give you 4.2 grams in 250 cm3, that you don't use it until you get to the end where they'll be asking of percentage percentage. So and if you look at this question here, you will see that there is no percentage in this question. So meaning you can use the idea that okay, since there's nothing like percentage in this question, so we are free to use that 4.2. So and that's the main reason why we can say we are using it here. So once again, CA and CB they are not known. CA and CB are not known, and now they say I should find CB. So what will I do to get my CB since I cannot use CAVA? So anything that is besides CB is what I will use. So and what is besides CB? That's this 4.2 grams in 250 cm3. So let me write it out here. So that means 4.2 grams in 250 cm3. So mean that here might be 4.2 grams. So in what? So I think that should be in 250 cm cube. Okay, yes. So it means what we'll be using now is 4.2 grams in 250 cm cube. So include that. So we include that. That's in 250 cm cube. So, and I told you the reason why we are using it here is because it's nothing like percentage. That's why we are going to use it to get our B. So to get my CB now, so as I've said earlier, that I will make use of this grams per dm cube so that I will now convert it to moles per dm cube. So here is our moles per dm cube now. So that's 4.2 grams in 250 cm cube. So change it to grams per dm cube by relating it with molar mass. So now I have my CB. So it will now be easier to get CA also using CAVA. So and that's how they got the moles per dm cube of this. Now the next one, calculate the number of moles of iron 2 ion in the volume of B pipetted. I said it earlier that when they say number of moles of iron 2 ion, so you can write it out. The number of moles of iron 2 ion in volume of B pipetted. So what I'm looking for is number of mole. I'll write it under as N, number of moles. Then in volume of B, remember B is always 25, so it means that's just write on 25 cm3. Then I said earlier, based on stoichiometry, since this one now is number of moles and this one is volume, I'll think of what other number of moles can I get for iron 2 ion. So the other number of ions I can get for iron 2 ion is what? 0.132. So 0.1, and how will I get that? That's from moles per dm. You know, I said once you say calculate mole, immediately remember what? Moles per dm. I wrote it here, remember moles per dm. So of what? Of that iron 2 ion. So let's go and check what is the mole per dm cube for iron 2 ion. So if you want to get moles per dm cube for iron 2 ion, so it is here already. So for iron 2 ion, that's for B. So moles per dm cube for your B. So and where is our B moles per dm cube? That's the new answer you got, which is here. So from the new answer, 0.132 moles per dm cube. That's for the iron 2 ion. So you now bring in that, okay, 0.132 moles per dm cube means 0.132 moles. That per means in 1000 cm cube, because per dm cube is 1000. So now it means we have mole on top, mole under, cm cube on top, cm cube under. So then you can cross multiply and get your moles. Now for 2017 question, they said A is 4.2 moles per dm cube of HCl. Then they use C this time instead of B. So don't always just stick to one method. They may say A and C, they may say A and B. So now they say C is solution containing 4.3 grams of sodium carbonate. But take note of the question here. They say XH2O. That means we don't know the water of crystallization, the number. So into 500 cm cube. So then do the same thing. The volume of pipette always 25. Draw your table. The concordant value, those ones are their difference is no more than 0.2. So put them, write them out. The average volume of A plus this 2/2, get your answer. Now the second, calculate CB in moles per dm. First, write out your parameters. That is, what is your A, ACO. Then your CA, you write it out, VA. So it means we have CA, VA, NA. The only CB we don't have, we have VB and MB, meaning we can use our CA, VA. But take note, if we say we also want to use CAVA here, we must look at the parameters complete. So if they are complete, we can use. So as you can see, they are complete. That's why we are using it. So CB, now we have moles per dm cube. Now they now say change the CB that is a mole per dm cube, change it to what? Grams per dm cube. Normally, we always say mole per dm cube, relate it with what? Molar mass, so that we can get grams per dm cube. But here we can't do that. Why is it that we can't relate mole per dm cube with grams per dm cube? I mean with molar mass to get grams per dm cube, because we cannot get the molar mass of CB. Let's come and check what is our B. So our B is sodium carbonate dust. They did not give us X. So and since they did not give us X, we can't get a complete addition. When you add 23 times 2, C as 12, everything, you can't get a complete number. So for your molar mass, so mean that we can't use relate mole per dm cube with molar mass to get grams per dm cube. So you rather get grams per dm cube from the given grams in the cm cube of B. So let's check our B. So in our B, this is the given grams in cm cube. So you use it to get your grams per dm. And as I said earlier, the condition whereby we are going to use this is if there is no percentage, if they not say calculate percentage. And that's why from the beginning to the end here, there's no question like percentage. So that is how to get this. Then the next one, they now say calculate molar mass of this. So this one, because of the x that is there, we say we can't just do it earlier. So this time you now, the same formula we are unable to use before, we will now use it. Remember that here for grams per dm, we're supposed to use moles per dm times molar mass, but we did not use it. We use another method. So, but now you now use it here. That means you now say, but this time the molar mass that we were unable to use, that is hindering us, so that hindrance will now be brought out. That new molar mass that we couldn't calculate be the subject of the formula, which is gram per dm over molar mass. So we will now say the gram per dm we have gotten before will now be the one that will take over here over moles per dm that we have already, which is 0.0992. So with that, you can get your new molar mass. So it's now complete 288. So that will now help us to get the x. Since we have gotten 288, then you can add all the necessary addition. The x will be there. Use it to get your x when you divide both sides. So that will be there. Then second to the last for today for this class is 2016 and 2015. So in 2016, they said A is a solution of 0.05 moles per dm, and here we are looking at oxalic acid. So for the oxalic acid or ethane dioic acid, we also have B is a solution of KMnO4 of an unknown concentration. So take note, they say put B into burette. Normally it's A, we always put, but now they say put B into the burette. Pipette 25 cm³ of air and so on. Now what will be our question? Let's start with the first question. Always remember volume of pipette used, that is 25. Then draw your table and get your concordant value, meaning that those two ones that their difference is no more than 0.2. Here now is one is just 0.1, which is very good. So then your average volume, you add the 2 over 2. Then the next question, calculate concentration of MnO4 minus in B in moles per dm. That's our CB now. To get your CB, write out what they gave you. So in our A, this is our oxalic acid. So put your CAVANA complete. Then move to B, KMnO4. CB is only what we don't know. We know VB and we know NB. So always remember that Na and Nb is from your formula here. So this 2 and 5, that's how they got this 2 and 5. So now with this, it means we can use CAVA since they are complete. So for CB, they say find CB, I'll use my CAVA to get it. Then next we'll calculate concentration of KMnO4 in B. So that's our CB now in grams per dm. Since we have it in mole per dm, so just use your grams per dm equals to relate it with molar mass. So when you relate it, we have your grams per dm. Now, this was what I was using to explain from the beginning of the class. They say calculate volume of CO2 evolved at STP. That STP means standard temperature and pressure. They use it for gas because CO2 is gas. So we want to get the volume of gas at STP. When 25 cm³ of oxalic acid reacted completely, all you just need to do, as I said, is that CO2 and the oxalic, they are the only two things you go and bring out from your chemical equation. So look at the chemical equation here. So just bring out this and bring out this because they are the only two things they reference. So when you bring both of them out, what will you now do? So take note that there's 5 moles at the back of this, bring it out. There's 10 moles at the back of this, bring it out. Equate them. Then from what they say you calculate, they say calculate volume of CO2. Normally I'm supposed to write VA, that's I'm looking for volume of CO2 when 25 cm³ of oxalic, then I should write 25 here. But I decided not to write volume. I left only the 25 cm³ as based on my normal principle, but I did not put my VA. Why? Because from this place we have already written mole and mole. So meaning that instead of writing V, I have to make sure I leave it as mole first, then later I'll change it to volume. So if I leave this one as mole, then I'll look for how this cm³ will also have mole. How will cm³ have mole? I'll remember moles per dm³. And moles per dm³ of what? Of this oxalic acid, which is, so if you go and check it, you see the mole per dm³ 0.05. So then the 25 dimension here, you now multiply, and always remember to change it to dm³. So over 1000, any value you get, then you cross multiply, use it to get the mole that we first said we'll calculate here. So after getting the mole, that's the mole of CO2. You now say normally 1 mole of CO2 is 22.4, that's at STP. But now that we have 0.025, what will it give us? Cross multiply. You have your answer in CMQ. But if you want to change it to DMQ, divide it by 1000. So then the last question for this class is 2015 question. So A is 0.1 moles per dm cube HNO3. B is a solution containing 2.5 grams of the mixture of sodium carbonate and sodium sulfate in 250 cm cube of solution. So do the necessary things. First thing, volume of pipette, always 25 cm cube. Draw your table, bring out your concordant values. Those ones are different, should not be more than 0.2. So here is one is 0.1. So bring these two values together over 2. So you get this answer. Now they said calculate CB in moles per dm. First thing, write out your parameters. Indicate the name of your acid, name of your base. But here you see that it did not indicate the name of acid. Why? Okay, it means that one must be a mistake. So it's HNO3. So I thought it was not there. So normally I'm supposed to start by saying my A is what? HNO3, so that it will be easier whenever you are looking for what is A, so let it be your parameter. So A is what? HNO3. Then you say what is your Ca. So from the question they told us what the Ca is. Va, that's your Titan value. Na, you go and check your HNO3 from your chemical equation. So see it here is 2, so you put it there. Cb, they did not give us. Vb, that's for your pipette. Then Nb, you check your base. So like I said, always know the name of your chemical. So here now they mention sodium carbonate and sodium sulfate. So in this chemical equation is sodium carbonate they mention. So meaning that here I supposed to write the B also for what? Sodium carbonate. So B here equal to my what? Sodium carbonate. So after writing out all this, it will now help us to know which formula to use. For example, now here now we are looking for what? CB and A, all the A, CA, VA, they are complete. Only CB is not known, VB and MB. So we can use our CAVA formula so to get your moles per dm cube. Now the answer in grams per dm cube. So relate it with what? Molar mass. Get your answer. Then finally, they say calculate percentage of sodium carbonate. So anything percentage. So it means you use your pure over impure then times 100. So from the question here, that's why I underline it again. That whenever you see grams separated from CMQ for our B, so you always use it at the end, especially if there is percentage in the question, use it at the end. So and that's why now at the end here, I brought the 2.5 per 250, I brought it to the end. So always remember to change it to dm cube over 1000. But the one on top, grams per dm cube, it will be from the calculations. So from the calculation, I have 4.74. So this is it here, and that's where we are going to stop for today. So thanks for listening.